Hi, this is Robert from Part Fusion Electronics. Last week I did a video around supercapacitors. So I made up this simple circuit, connecting up a supercapacitor with the charging and then a kind of discharging here. So we can just see that the LED here is almost visible. If I turn the light, if I hide the light, you can see that it's just about lighting up. You can see that it's 1.5 volts. So there's still quite a bit of capacity left in the supercapacitor, but it's not we're not able to use it to light up the LED. So it's kind of turned off now. It's almost turned off. So what I wanted to do this week is design up a basic kind of boost circuit to try and step up the voltage up to something more usable for driving an LED or a microcontroller or something like that. So what I'd ordered a couple of weeks ago was from LCSC is just a kind of a generic but very cheap step-up DC to DC converter. So this is an ME2188 and it's a 3.3 volts. So this will step up a voltage from about 1 volt up to 3.3 volts. So if we look to draw out the basic basic circuit diagram of the boost converter is you have your chip. So this is a 3-pin chip. We'll have ground. Use our ground symbol. We'll have our voltage source. And between the voltage source and the 2188 is actually there's going to be an inductor in series, and then the output voltage, and that would go into our load. So we just have a simple resistive load, and we might need a capacitor. I don't know yet if we're going to need a capacitor on the input and the output. So that's the kind of typical, circuit that you would have for using this kind of boost converter. So where I am now, I don't have access to advanced circuit, the ability to create my own circuit boards. So what I'm going to use is a bit of strip board here. But if we look at the chip itself, as I said, it was an SOT. Oh no, I don't think I said that. It's SOT 23, and it's like the 3-pin version. So that's actually a very small chip. So you can see here, you're going to need to use I shouldn't lose it. You need to use tweezers realistically to work with this. Bring it up to the camera. So the pin out of the package is something like this. There are 3 leads there. So this bottom one here is our ground, and this is what they call the LX. So that's this input side of the chip, and then the top here is V out. And if I take my strip board and I place the chip onto it just about lines up. So if I'm careful, cut the trace on the bottom here, I can solder it and have all 3 pins available to solder in some like jumper wires and add in the inductor in series. So that's what I'm going to do now. Here's my inductor. So this part here, the inductor. So these are at 22 microhenries, and the example gives this as at 100 microfarads. The input is like a 10 microfarads. So they may not be required for a stable circuit. I only have a 22 microfarad capacitors, so I could connect up a number of those to give the suggested output capacitance. What I'll do is I'll try it without that and see if the circuit ends up being stable. Between the USB and the supercapacitor, I wanted to put a resistor. So I have some surface mount supercapacitors. So these are 0603s, which is at 2 millimeters by about 1 millimeter. Again, usually would use a made circuit board rather than this kind of strip board, but if you kind of know what you're doing, it can be very good to experiment using this kind of technique. Okay. Found it. I just thought I'd lost the chip there. So my ground pin is now connected in. I haven't got great light here. So if I solder in the other pins, do this V out pin. Far from my best soldering. As I said, we're kind of just prototyping. The circuit. Get one of my inductors. So now I have my inductor connected in. I'll grab some wire. It's just standard hookup wire, solid core. So this was the ground. Bring it down to the ground pin of the USB connector. So the strip board is normally used for through-hole components. So I'm kind of working on the soldering side of the circuit board. But because surface mount components usually go on the solder side of the board, so I'm kind of working on the wrong side. So if I put my resistor in series with the 5-volt pin of the USB, if people were interested, I could do a much tutorial on surface mount soldering by hand. You don't need magnification to do this. So my ground is going to go in something like that. So I need to bring my 5 volt pin from here to here, and then I bring the 5 volt from here up to here. One thing I'm going to have to figure out is how to solder this into my circuit board. I guess I could put it on that side. It's probably the correct way to do it, though it will mean my circuit board is lopsided. Or I could maybe use something like this kind of pin header. So I could make it reusable or easily removable. I'll have a think about that. What I'll do now is connect this trace up to here, and then I kind of everything soldered into place, so then I can test to see if the what the DC converter does when I give it 5 volts, because it is meant to be a step-up converter, and I'm using it with a higher voltage than I'm stepping up to. It might go pop. I don't know yet. But probably because I have the this resistor in series, there may not be enough current. I limit it to 100 milliamps with the 50 ohm resistor in series. Take a multimeter, put it into kind of continuity mode. Ground to ground. Ground to 5 volts. Ground to 5 volts. Ground to output. Okay. So nothing jumped out of us there, so let's try connecting it up. Fingers crossed. Okay. Check our output voltage, or check our input. So it's 5 volts. 5.1 input. It's not warm to touch. I forgot this has a torch. Okay, so it's 5.5 or 5.1 output. And I'm only getting a 3, no. 5.1, 5.1, and a 5 volt output. Okay. It's Not exactly what I was hoping for. So the step-up converter is passing through the full 5 volts. So what I probably have to look at doing is maybe finding another chip that's a step-up, step-down converter, or working with the 5 volts. But while I'm here, let me solder my supercapacitor into place. So now the supercapacitor should be charging up. Let me try using something other than this battery bank. Interesting, I'm not sure what's happening. I think I might take a little bit of a... I think I'm going to have to come back to this. Can anybody see what I'm doing wrong? Have I maybe... Have I burnt out the voltage regulator? Or is the it's maybe something to do with the supercapacitor? Let's see if I can remove the supercapacitor from the circuit. It's not charging up. I don't think it'll have damaged the supercapacitor. I might just try charging the supercapacitor from last week's circuit. Let that charge up for a minute. Actually, let's measure that. Okay, so that's charging okay. Okay, so it's 5.1 off the USB pin, 5.1 after the resistor, 5.1 volts before the inductor, 5.1 after the inductor, ground is 0. And then the output from the DC to DC converter, step-up converter, is 5.1. Interesting. Maybe I've blown it. The supercapacitor voltage is 3.4. Let's disconnect that. I probably should have soldered some sort of LED to the output. So if anybody watching can see what I'm doing wrong, you maybe could leave a message in the comments. I may have to go back to the kind of drawing board and pick a different type of DC to DC converter. A SIPEC, can't remember. It's basically a step up and step down converter in one. One of the reasons for going with this DC to DC converter was very cheap. It was about 8 cents, US cents. So I think the supercapacitor is okay. So it's probably something wrong with my circuit. So there it's still supplying voltage. So it's 3.3 volts. And with no load. It's 3.4. So if we put it back in circuit, 3.3. Yeah, so I think I may have damaged the DC to DC converter. So what I might try and do now, I can put that back charging, is removing this one. So it's quite possible that by having the input voltage higher than my target output voltage, I end up damaging the DC to DC converter, which isn't going to work for my intended design. Unfortunately, I don't have access to an oscilloscope here. I'm in Boston at the moment. So another possibility could be that it's unstable, as the circuit diagram does suggest, and it's quite common for these types of circuits to require a suitable amount of input and output capacitance. And I said I was going to be the last thing, but let's try throwing some capacitance on the input and output. But if I was laying out this circuit on using schematic capture, I'd almost certainly have put, the required capacitance in. Okay, let's call that a day for the video anyway. I think I'm over an hour now. Anyway, thanks. I'm not sure what I'm going to do next with this. If you like this, subscribe, like, or dislike, probably dislike. Subscribe, you can follow me on Twitter. Thank you.